Okay, so if you just hopped on, hi, we're going to get started. If you missed the girls' basketball game tonight, you missed a show. They won. It was a great game. Mr. G is screaming in the background. Congratulations to you guys. And we're going to get ready for our test on Thursday. So this is covering Unit 4 for 1 through 4-9, which is all of sort of analyzing functions by using the derivative and the second derivative. And we call that a lot of the times curve sketching because we're getting an idea of what this curve looks like. So the front of your review sheet has sort of the basics of what you're going to need to know as far as different types of tests. So testing for increasing and decreasing, testing for the relative extrema, testing for absolute extrema, testing for concavity, and testing for points of inflection. Those are all things you're going to need to be able to do. And we reviewed those when we did 4-9, but we're going to go through those again algebraically and graphically tonight. If as we're going through this, you have any questions, send me a message on Remind or type in the chat and we'll go from there, okay? So I'm not going to do every problem, but I'm going to sort of hit one of every type and then a couple that were a little bit more difficult off of here. Again, the key to this is on OneNote, so feel free to look there. So the first one, we're using derivatives to determine the intervals on which this function is increasing and decreasing. Now, if you think about increasing and decreasing, remember that would look like increasing would look like that, decreasing would look like that, right? So we're talking there about slopes. Something will be increasing when the slope is positive, decreasing when the slope is negative. So since we're talking about f, it's increasing when f prime is positive and decreasing when f prime is negative. So I'm going to start by figuring out what f prime is. So if f of x is x cubed minus 3x squared, f prime would be 3x squared minus 6x. Now I'm going to find the critical values by setting that equal to 0. And that will never be undefined, so I don't need to worry about that. And here I can factor out a 3x, leaves me with x minus 2. So I get critical values at 0 and at 2. And those are what I'm going to use on my sign analysis. Now, remember that for increasing and decreasing, we care about the slope, right? And so for the slope, that means I'm going to plug into f prime because f prime is the slope of f. So I'm going to plug into this, and you can think about this in a lot of ways. You can do the number of negative zeros or factors. You can think about the end behavior, or you can just plug in. So this I see as quadratic. It's positive leading coefficient, so its ends would go up, up, and that middle would be down. You also can just plug in, right? That's always another option you can plug in there. So that's my sign analysis for this. Again, plugging into f prime. So what I know here is that f is going to be increasing on negative infinity to 0 and 2 to infinity. And again, you can put a union there, you cannot. It again depends on who your professor is next year in calculus. Some professors will argue one way or the other. And that is because f prime is positive. And then f is decreasing on 0 to 2 because f prime is negative. One of the things I see most often on this test is that people just don't say like why, right? If it says explain. In this question, it didn't say explain, but if it did, make sure that you're explaining. Okay, if you have questions at any time, send them. Otherwise, I'm just going to keep working through some of these, make sure we have the basics. So the next one is a little bit more of a scenario. So 8 is a critical number. So that means that f prime of 8 equals 0 or f prime of 8 does not exist, right? One of those two things, but it's a critical number. We know f prime is positive on 8 to 9 and f prime is negative on 7 to 8. So I'm going to draw a number line. I'm going to use 8 as my critical point. And I know f prime is negative from 7 to 8 and it's positive from 8 to 9, right? I don't know what it does before or after, but I at least know that. What occurs at the graph of f at x equals 8? Well, since x equals 8 is a critical value, we know that that's a candidate for an extrema, right? And our slope, our f prime, is going from negative to positive. So think about what that would look like. This is a relative minimum on the graph. Okay, so the next one is we're going to be looking for absolute extrema. And remember, absolute extrema, yes, we care about the turning points, but we also care about the end points because those could also be our absolute maxes and mins. So we're going to do the same thing we did with relative extrema to start, and then we're going to go back to the actual extrema or the actual function to find out what's the highest and lowest. So I'm going to start by finding the critical values, which is, let's see, f prime is 12x squared minus 4x cubed. Set that equal to 0. So I'm going to take out a 4x squared, and that would leave me with 3 minus x. So I get x equals 0 and x equals 3 as my critical values. Now, I'm not looking for a turn here, right? This isn't a relative extreme. So I'm not looking for a turn. So I'm looking just what's the highest and what's the lowest. So here, I'm going to plug x back into f of x. So I'm going to plug in my endpoints, which was -2 and 3. And I'm going to plug in my critical values, which was 0, and then I already have 3 there. Remember, you only need to use critical values that are on the interval. Those are your only candidates. So now plugging those back in, here you would do 4 times -2 cubed minus -2 to the 4th. So that's 4 times -8, so -32 minus 16. So that's -48. Plug in 0, you get 0. And plug in 3, you've got 4 times 3 cubed minus 3 to the 4th, right? So that's 4 times 27 minus 81. And 4 times 27 would be 108 minus 81, which would be 19 plus 8, 27, right? Now, you also need to be careful with what your maxes and mins are, what it's asking for. If it says find the absolute extrema, that is asking you to find the y values. So the way you would phrase this is you'd look at your chart and say, okay, the maximum is 27. So I would say there's an absolute max of 27, right, of the y value at x equals 3. And the minimum is -48. There is an absolute min of -48 at x equals -2. But remember, if I'm asking you for the absolute extrema or for the relative extrema, I'm saying what are the y values, right? Okay, let's go to the next one. So find the points of inflection. The definition of points of inflection are where concavity changes. So it's where the sign of your second derivative changes. Because remember, your second derivative tells you about the concavity of f. So knowing this, points of inflection, I'm going to have, okay, let's find the second derivative. So f prime is 24x squared minus 4x cubed. And that would make f double prime equal to 48x minus 12x squared. So let's find where that equals 0 or doesn't exist. I can factor out a 12x, and that leaves me with 4 minus x. And so that has zeros at 0 and at 4. So those are where my concavity might change. Now, plugging into this, I get negative, positive, negative. And again, you can look at number of negative factors, or you can look at your end behavior, whatever you want. And so think about what this means. If your second derivative is negative, second derivative negative means we're concave down, right? Second derivative positive means we're concave up. Second derivative negative means we're concave down. So there are two places here where my concavity actually changes. It would be at 0 and at 4. And you're really looking for that sign change. If there was not a sign change there, it would not be a point of inflection. Okay, send questions again. I'll remind if you guys have them. Okay, next one. Find local extrema. So again, this was absolute extrema when we have to look at the endpoints. Local or relative extrema, you're looking for that turn, right? So I'm going to start by finding f prime, which would be 3x squared plus 12x minus 36. Let's find the critical values. So I can take out a 3. That would give me x squared plus 4x minus 12. And so that's x plus 6, x minus 2. So I've got critical values at -6 and at +2. Now, if you look at your behavior there, that's going to go positive, negative, positive. So right there, our derivative, f prime, is going from positive to negative. And so that's going to be a relative maximum. Here we're going from negative to positive, so that's going to be a relative minimum. But if it says find the local extrema, it's asking you for the y value. So here, I know that's going to be a max, right? And so we need to figure out what that value is. So I'm going to plug -6 into f. And I'm going to plug 2 into f. And remember, this one will be my max value. This one will be my min value. And your answer should be those y values. Okay, we are going to skip through some. So if you have questions on some, feel free to ask. But we're going to kind of skip around a little bit from here. I wanted to get one of sort of each of the basics done, and then we'll come back. All right, the next one, the derivative of f, we're looking at number 7. So the derivative of a function is given by this. So this is already f prime, right? Where x is greater than 0. And f prime of 1 is 7. Or f of 1 is 7, I'm sorry. And I want to know on what intervals is the graph decreasing and concave up. So let's think about this. Decreasing would mean f prime is negative. Concave up would mean f double prime is positive, right? So that's what we're looking for here. So I need to analyze f prime and I need to analyze f double prime. And we're going to do that separately. So let's start with f prime. So the derivative of f is given by this. This is f prime. So f prime equals x minus 3 e to the x, right? So since that is f prime, I'm going to set that equal to 0. And e to the x will never equal 0, but x minus 3 would equal 0 at 3. So this has a critical value at x equals 3. Now, if I plug into this, right, there's 3, then I'm going to have, I'm going to have to check f prime for that sign analysis. So if you plug in a number less than 3, let's say we plug in 0, right? So this factor would be negative. This factor, e to the 0, is just 1, so this is going to be a negative. If you plug in a factor bigger than 3, it's going to be positive. So f is going to be decreasing on this interval. I know that's what I'm looking for. Now, where would f be concave up? Now we have to look at f double prime. So f double prime is, we're taking the derivative of this, we're going to use product rule. So the first times the derivative of the second plus the second times the derivative of the first. So there's my second derivative. And I'm going to set that equal to 0. Now, what some people were doing here was getting stuck on what to do next. I would say, notice that this term and this term each have an e to the x, right? So I'm going to factor that out to the front. And that leaves me with x minus 3 plus 1. So this is really e to the x and then x minus 2. Now again, e to the x will never equal 0. This will equal 0 at 2. So my sign analysis for this, and I'm going to do it over here. So 2 is my critical value. If I plug in a number bigger than 2, this will come out positive, and less than 2, it will come out negative. So I'm looking at this being where this is concave up. So let's look at the overlap. We've got this interval from 2 to 3 where my function is both decreasing and concave up. So here what I would say is it's the interval from 2 to 3 because, and notice it said explain, f prime is positive and f double prime is negative. Okay, again, if you have questions, send them, but we're just going to kind of work through these, jump around a little bit so we get a little of every topic. Okay, next one, number 9. This was one a ton of people had questions on in first block, I know, and fourth block, you guys didn't get to work on this in class, but this is an optimization question, so often we have questions on this. You guys did so well on your optimization on the quiz. And so I want you to like bring that same thought process that you use in your groups to when you do this on your test. In your groups, I heard the best conversations. What are we trying to optimize? What are our constraints? What do we know? And then from there, you guys really did amazingly with this. I know these are tricky, but we're not talking about a test that's made up of mostly these. We're talking about a test that's made up of a few of these. So don't fret if this feels tough, but think about what are you optimizing? What are your constraints? Rewriting it in terms of one variable, and then go from there. So number 9, that's the one we're going to look at. 8 people seem pretty good with. 10, you can look at my key if you want, or we can go over it later if somebody would like to ask live. But we're going to start with 9. So we have 45 meters squared. Notice meter squared, that's telling me that that's area. To build a box with a square base and no top. So, okay, 5 sides, right? And I wanted to determine the dimensions that will enclose the maximum volume. So our constraint here is our surface area. 45 equals the surface area, and we'll come up with an equation for that in a second. We are optimizing volume, right? So this is surface area, this is volume. So I need an equation for volume. So I'm just going to kind of draw myself a picture up here. So they tell me that this is a box, right? And it has a square base. So I'm going to call that X and X and no top. I don't know anything about the height, so I'll just call that Y. So the volume is going to be area of the base times the height. So X squared Y. This is what we're trying to optimize, right? And the constraint is your surface area. So let's think about the area here. And I'm going to use some color coding. So if I do the bottom here, right? What's the area of the bottom? Well, that would be X squared. And there's no top, so we don't need to worry about that. Now, these sides, this one is Y tall, X wide, so that would be XY. But so would this one, right? Because the base is square. So all of your sides would actually be the same. So I would say plus 4XY. So there's our constraint. There's what we're trying to optimize. And we can now use these to get this in terms of one variable. Okay. So that's what I'm going to do. So I'm going to always take my constraint and plug it into this. So for the constraint, let's solve that for a variable. So it's going to be the easiest there to solve it for Y. So it's going to be 45 minus X squared equals 4XY. Divide both sides by 4XY. So Y equals 45 minus X squared over 4X. Now, you could simplify this here, or you could wait a second, doesn't matter. I often feel like it's easier to simplify here. So you could make this 45 over 4, and then it's over X, right? And then minus X squared over 4X. And you could simplify that to be 45 over 4X minus X over 4. So again, you don't have to simplify it here, but you can. Now, let's substitute that in. So this is going to become X squared, and then instead of Y, I'm going to put in this. And again, you can put in this expression, or you can put it in that expression. It doesn't matter what you put in. So I'm going to go with the one on the right. So 45 over 4X minus X over 4. And I'm going to distribute that X squared out. So this would be 45X over 4 minus X cubed over 4. So there's my volume function. And again, I've done no calculus yet. This is all just figuring out what my optimization equation is. So now let's optimize this. So V equals 45 over 4X minus X cubed over 4. And I would remember that X cubed over 4 is the same as 1/4 X cubed, right? So V prime is going to be just 45 over 4 minus, bring down the 3/4 X squared, right? Now we're going to set that equal to 0. And I'm also going to multiply everything by 4. So that gives me 45 minus 3X squared. So that gives me that X squared equals 15. So X is plus or minus square root of 15. Now, let's make sure which one's a maximum. And again, this is a dimension, so it makes sense that it should be the positive one, but you always want to double check with your sign analysis. So here, this is going to go negative, positive, negative. And so the maximum is going to occur there, right? That's your max. That's where we go from positive to negative. So that tells me, and it wants the dimensions, so that tells me that x is going to be radical 15, right? And y is going to be, we need to plug back into there. So this would be, and you can plug back into either spot, but 45 minus radical 15 squared over 4 radical 15. That's 45 minus 15, so that's 30 over 4 radical 15. And you can reduce that, but you don't have, it doesn't say like simplest form or anything. So your dimensions would be x and y, and those are each in meters. That's a tricky one. Okay, send questions as you have them, guys. You are very quiet tonight. All right, let's look at 11. So this is what we did, fourth block today, first block last week on the very snowy Friday. And so remember that what you want to really look at is what this is a graph of. This is a graph of f prime, right? This is a graph of your derivative. So in other words, this is a graph of the slope of f, right? So that's what we need to think about. So here, for what values is f increasing? Well, I usually start with the justification. So f will be increasing when f prime is positive. Think about this graph where that's happening. That's anywhere we're above the x-axis. So that would be anywhere up there. So from 1 to 4. Now, where does f have a relative minimum? So that's going to happen when f prime changes from minimum, we're going a negative slope to a positive slope, right? Negative to positive. And so where is that happening? Well, we are negative all in here. We're positive up here. So we are switching from negative to positive right at that point. So at x equals 1. Where does f have a relative maximum? So we should be going positive to negative here. This never happens because f prime does not change from positive to negative. And then the last one is concavity. And again, this is normally where people start to get stuck. Concavity is a little bit trickier. So here's what the thought process I go through with concavity. If f is concave up, I know f double prime will be positive. What that tells me, remember f double prime is the derivative of f prime, aka the slope of f prime. So that tells me the slope of f prime is positive. Or f prime is increasing, right? So looking at this, where does f prime have a positive slope? Well, as a positive slope there from negative 4 to negative 3, right? And then it has a negative slope here. And then a positive slope there, so from negative 1 to 3. And that's it. If you start with the justification, these become a lot easier because when you justify first, you know what to look for, right? Okay, I've only got a couple more questions, guys. So if you don't send me some questions, it's going to be a very short live stream. So, all right, multiple choice. A lot of these are pretty straightforward. This one, there was an error on the key, so make sure you look at the remind I sent you. It should have been E. And the one I wanted to look at next was 5. So 5 says we've got this graph of f prime, which could be the graph of f. This takes a lot of thought. This one's a little bit more critical thinking. So f prime, let's see what we notice. F prime here is always greater than 0, right? Which tells me that the slope of f is always greater than 0. That's what f prime is, right? So A has a negative slope there. B has a negative slope there. C has a negative slope there, right? D and E both have positive slopes the whole time, which is good. It means it's one of those. So we can at least narrow it down to one of those answers. Now, deciding between these is weird because they seem like they're the same shape. So here's what I would do if you're stuck on that. I would pick a value and see what the slope is around there. So like, let's say I pick this value out here toward the end of the graph. Do we see that that slope, or f prime, is almost 0 there? Right? F prime is almost 0. So since f prime is almost 0, that means my slope out at the end should almost be 0. That is not true at D. Out at the end, my slope is vertical, right? Or my slope is undefined. On E, the slope out at the end is almost 0. So I know this should be E just by considering what those slopes actually are. And again, that one's tricky. Okay, let's look at 6. So 6 said, at which points on the graph of f of x, so this is the original function, is f prime greater than f double prime. Now let's think about what these tell me about. So f prime should automatically make me think about whether something is increasing or decreasing, right? F double prime should automatically make me think about concavity. So let's consider each of these points. At letter A, right? F prime, well, we have a negative slope, so f prime would be negative. F double prime, that's concave up there, so that would be positive. Okay, at B, we have a positive slope, so f prime is positive. It's concave down there, so f double prime would be negative. At C, f prime is pretty much 0. It's almost 0. And f double prime would still be negative because it's still concave down. So let's see here which one of these has this f prime bigger than f double prime. Here, f prime is negative and f double prime is positive, so it's not that. Here, f prime is positive, f double prime is negative, so that one works. Here, f prime is 0 and f double prime is negative, so that one works. So B and C could both be right there. Okay, and then this was the last one I was going to talk about. So on number 8, looking at this one, it says, at which point is dy dx greater than 0 and d squared y over dx squared greater than 0? So first derivative and second derivative. The first derivative is greater than 0 at anywhere that y is increasing, right? First derivative positive, y is increasing. The second derivative is greater than 0 means y is concave up, right? Second derivative concavity. So let's think about where this is increasing and concave up. At A, it's decreasing, not that. At B, it's increasing. At C, it's increasing. At D, it's flat. At E, it's flat. So it's got to be B or C. So then from there, which of those is concave up? Well, let's look at the curvature. Down here, there's our curvature. Up here, there's our curvature. B is the one where it's concave up like a cup. So my answer would be B. All right, guys, that is all that I had planned. So I'm going to hang out for a couple more minutes and see if you have questions. I will throw the link to last year's live stream in the description box down below this on YouTube. So check there once this is on YouTube. And otherwise, I'll sit around here, wait for questions. I will be after until about 3 on Wednesday, and I'll be there early Thursday. And if we have a delay, we will still have the test. If we have a snow day, obviously we won't. Don't be afraid to be the person that asks. Somebody else will appreciate your question. Anything? This is it, guys. Any final questions? All right. If nobody has anything, I will upload this to YouTube in the next 10-15 minutes. It'll be up there. Send me questions as you're studying. You guys are going to rock this just like you rocked the last one. And I will see you guys on Thursday.